Hello, PreCalculus student. This video is for chapter 3.4, part 3. We are going into the understanding or trying to find out how to write formula of a polynomial functions. So these two are actually the most important things of this one and the one that we just covered, which is if you have a polynomial function, after you factor it, how can you draw the pictures of the polynomial function without using your graphing calculator? And the other one is if someone gives you a formula, how can you write a polynomial function out? Although this is not as important as the last one though, but it gives you a better understanding on how the graph and the formula are related. So to write a possible formula for polynomial functions, of course you have to find all the zeros from the graph. Write down the multiplicity or the least multiplicity, right? So if it is odd, then the least one would be either 1 or 3, depending on how it cross the zeros. And if it is, or it would be 2 if it bounces off, right? So, and then you write the polynomial function as a product of all the zeros minus h. H is the zero, x minus h to the power p, where p is the multiplicity. So you need to find all the h and the corresponding p, and then the function, I should say f of x or p of x, is the product of all those 0 minus h to the power p together. So, and then you need to give a coefficient a before the products. So you need to solve for a because a is something that you don't know. So you would choose a point, usually the y-intercept. You can read off the y-intercept unless the y-intercept is not a whole number. If not, then you use it, and you would be able to solve for a, and then that would be the formula. So for example, someone tells you this, that they don't give you the graph. Oh, here, let's do this one. We have the graph, so let's write down all the zeros. So the first zero is zeros is -3. Multiplicity is p equal to 1 because it goes through it, right? And then there is another one is equal to 2. The multiplicity is equal to 2 because it bounced back, right? Then the next one is 5. Multiplicity is also 1 because it just through it. So we will say, and then I have a y-intercept of 0, -2. So we will say y-intercept 0, -2. So these are the important things that you need to collect. First, you will write y equal to a, have all those x minus, minus -3, that means plus 3 to the power 1, x minus 2 squared because multiplicity is that, and then x minus 5 to the power 1 with a. So that is the preliminary version. And then you are to plug in 0, -2. So -2 is equal to x equal to 0, a times 3 times -2 times -5. So in this case is 10, it's 30a, right? So a equal to a times 30 equal to -2. So a equal to -1/15. So in other words, the formula for this function could be y equal to -1/15. What do we have? X plus 3, x minus 2 squared, and then x minus 5. So basically you write it out with the a in the front, with all the zeros following it, with the multiplicity, and then you solve for a using the y-intercept. The second one is you don't even give you the graph, they just tell you the zero, they tell you the multiplicity, and then the y-intercept. So you would write a preliminary one, which is y equal to a, open parenthesis, x minus -5 means x plus 5, x minus -2 means x plus 2, x minus 1. They all have multiplicity of 1, so that's very easy to do. And then you would need to solve for a by plugging it 6 equal to a times 5, because 0, 0, 0 times 2 times -1. So this is -10. So a is 6 over -10. That is a equal to 3/5. Oh, -3/5. So the formula itself would be f of x, or the function itself, would be negative 3 over 5, x plus 5, x plus 2, x minus 1. That's it. Example 3, degree 5, roots of multiplicity 2 at x equal 3 and x equal to 1. Single root at x equal to negative 3, y-intercept at 0, 9. So degree 5, the roots is multiplicity 2 at x equal to 3. So they talk about the multiplicity first. So 0 is 3. Multiplicity is 2. And then 0 is 1. Single root, so p equal to 1. Oh no, 0. Okay, so this means at this 2, the multiplicity is 2. So I should say p equal to 2 also. I misunderstood the way. Single root at x equal to negative 3. So negative 3, it is 1. So we have 1 root, 2 root, 3, like that. So it is fifth root, right? 5 degree, 1, 2, 3, 4, 5. So I'm going to write the preliminary version, which is a, open parenthesis, x minus 3, x minus 1, and x minus negative, that means x plus 3. Which one is square? These two. Okay. Now I need to do 0 times 9. 9 is equal to a times negative 3 square, negative 1 square, and 3. So that would equal to 9 times 3 is 27. So 27a equal to 9. So a, if you go here, a would equal to 9 over 27 equal to 1/3. Okay, a 1/3. So the equation is y equal to 1/3. X minus 3 square, x minus 1, and x plus 3. Oh, this is also a square. So the zeros can help you to determine, and multiplicity help you determine the exact polynomial function. You don't need to multiply them out. You can just write them in factor the form. Okay. We have the last two things is about, we talk about how to graph it. When we graph, we also talk about how do I know how high the turning point goes. We can. So the way we can do is, so for example, is to use the graphing calculator. Before we know calculus, in calculus, you will learn how to do those what's if like local maximum or minimum. So those are called local because it is the highest or the lowest around its neighbors. So I have a function x to the 4 minus x cubed plus 1. I want to write the maximum and minimum if exist, the local. So I'm going to do use a decimal, right? So y equal to x to the 4 minus x to the 3rd. What was it? Plus 1. Plus 1. So this seems to be the local. So it's hard to see. So this, I don't think this is a local one. This is kind of like a flat area. This is the only one that's like go down. And also the two things like shoot up. So we should not expect there is any turning points on the other side. So the only local minimum, or actually it is a global minimum, would be 0.75, 0.895. So you click on it, decimal will show it. 0.75. So you will draw it. How does it look like? Kind of like that. So you can see that there's no x-intercept. So that's why in those cases, algebra cannot help you to graph it. 0.895, and you would need to use calculus to do that. The last one is about solving polynomial, writing the polynomial equation. We have done similar things to before, so we'll just practice this again. There's a rectangle of length 12 width 10, and then you are to cut 12, 10. You are to cut square of x and x. Remember the same thing that we have did before. And then they will form a box, right? and you are to find the polynomial function and then write the domain. So we have done this before. After you cut off x, 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 so the width is 12 minus 2x. The width is 10 minus 2x. The length is 2x. So we would have a 12 minus 2x length box and 10 minus 2x width box and an x. So v would be x times 12 minus 2x, 10 minus 2x. Right? So that's the v. What is the domain? The domain would be the value that is possible for x, and we talked about those before. The maximum you can cut this x is when it is cut in the middle. So we say it's 0,5, right? Not including 5. If you include 5, then there's nothing, and not including 0. So this is the polynomial function. It is a polynomial if you multiply it out. You can spend some time to multiply it out, but I don't want to go into this. But this is good enough. It's a factor form of a polynomial. When you do calculus, sometimes you need to multiply it out to be easier. Sometimes factor is fine. When you solve equation, factor is fine. This is a domain. So a box, the second one, a box has a length of 2x plus 1 box. Okay. Oh. So this is 2x plus 1, and the width is x plus 2. Height is x. Find the volume as a function of x and the domain. So v would equal to 2x plus 1, obviously, just multiply length with height, right? X plus 2, and then times x. So what are some possible value of x? Well, x has to be positive because x is a height, right? Other than that, I think there is no restriction because there is no subtraction here. So long as the length, width, and height are positive, that's fine. So you will say from 0 to infinity as the domain. And so that is all of 3.4.